data multiplier, this time 8 cross 8, 8 bit cross 8 bit, and this matrix with all the partial products. Each and every partial product is represented with a dot. We don't carry forward always, we don't talk about A into B always, so it's a standard arrangement. So we have all the partial products are mentioned in a dot. All right, so this is the rearrangement of this one. Up to this one, see, watch carefully, up to this column, it's a, we don't disturb up to this column. Up to this column we don't disturb this column. The column height is 1 2 3 4 5 6 7 and 8. See, 1 2 3 4 5 6 7 and 8. After this column is pulled up as it is. This is placed over here, and this is placed over here, and this comes up and occupies this position. This PP partial product occupies this place, and this one over this, and this finally over this. That's what it has happened over here. In the sense, all these, this comes up occupying this place, this comes up occupying the place over here, like that. So this isn't something different, a rearrangement of this one itself, this matrix itself. Now how making use of full adders and half adders, how we reduce the height, column height, how the column height is reduced making use of full adders and half adders. And remember, the next step, it's a 6, the column height should be reduced to 6, and then 4, and then 3, and then to 2. So in that process, guys, they followed something like D equal to 6 for a 8 cross 8 multiplier, in the sense column height with 6 partial products, we don't touch that. Other than 6, we reduce that to 6. All right, so starting from the LSB and moving towards the MSB, it's a column height is 1 2, the column height is 3. We don't do anything over here at this stage, no operation. We don't go for any full adder or a half adder. It's a 4, column height is 4, no. Column height is 5, no. 1 2 3 4 5 6, column height is 6, we don't do anything. But after this one here, after this, the column height is 7, 1 2 3 4 5 6 7, and so we have to reduce that to 6, making use of a which one, 1 2 3 4 5 6 7. Here we go for a half adder, we insert a half adder which produces this one, which produces a sum. Again the partial product is mentioned in a dot, and a carry over here, carry. All right, and the rest of the partial products are brought down as it is. 1 2 3 4 5 partial products, 1 2 3 4 and 5. Now the height is 1 2 3 4 5 and 6. All the columns are done with the same manner. All right, and here we making use of a full adder, making use of a full adder over here. This full adder produces a sum and a carry. All right, and it's 2 over here, 2 bits over here, 2 partial products over here. And what if we bring all these partial products down like what we have done previously? 1 2 3 4 5 6 and 7, no. So one of the partial product has to be reduced, and so we go for a half adder over here, which produces, this half adder produces a sum and a carry. All right, then can this be brought down? 1 2 3, that has to be brought down as it is. 1 2 3, making sure the next stage, in the next stage the column height is 3. 1 2, column height, I'm sorry, the next stage the column height should be 6. 1 2 3 4 5 and 6, of course. All right, in the same way, making use of a full adder over here, making use of a full adder over here, which produces a sum and a carry. We cannot neglect that one, a carry. All right, so we already have 3 bits over here, and it's a 1 2 3 4. If we drop these bits as it is, the height will be 7. No, our intention is to reduce the next, in the next stage the column height should be 6. So making use of another half adder over here, which produces a sum and a carry. So these 2 bits doesn't undergo any operation and brought down as it is. Yes, 1 and 2, bit 1, bit 2, bit 1, bit 2. Now 1, 2, 3, 4, 5, 6. The column height is 6. All right, that rule is being satisfied still. And definitely a full adder over here, a full adder, making use of a full adder here, which gives rise to a sum and a carry to the next stage, carry. And we have 1, 2, 3, and we have 1, 2, 3 over here. So 1, 2, 3 over here. So let's go for that. 1, 2 and 3. All right, and we have 1 bit which is a carry from the previous stage, and the number of bits are 1, 2, 3, 4, 5. Can we get the column of these bits to the next stage? Of course, for sure. 1, 2, 3, 4, 5, and here no operation needed over here. 1, 2, 3, 4, 5, and the column height is 6. Of course, 1, 2, 3, 4, 5, and 6. The column height is 6. All right. So these 4 bits as it is. 1, 2, 3, 4 bits, and those 3 bits also as it is, and 2 bits, and that single bit over that side. And over here, no need. We didn't perform any operation for this column. So this column, what's the height? 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6 as it is. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. The next one 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, and 1. This is the second stage where the column height is 6. This column, this one, we have a maximum column height to be 6. Now making use of the same full adders and half adders, the next stage to be the column height to be reduced to 4. All right, so 4, it's already 4, so nothing to be done with this one. This comes as it is. This comes, no change, no operation over that side. In this column, no half adder or no full adder. Here we have to go for a half adder. Why? Because the column height is 1, 2, 3, 4, 5, and in the next stage it should be 4. So making use of a half adder over here, which gives a sum and a carry, and these 3 bits as it is to the next stage. 1, 2, 3, making sure the column height is 4. 1, 2, 3, 4. All right, column height is 4. And here we already have a carry, going for a full adder over here, making use of a full adder over here, which produces a sum and a carry. All right, and we already have 2 bits, which is a carry and a sum from the previous stage and sum from the full adder. And can we drop down these 3 bits as it is? No, the column height will be 5. We want that to be 4. So making use of a half adder over here, this half adder produces one sum and a carry. All right, and this partial product doesn't undergo any operation and can be reproduced as it is over here, making sure the column height is 1, 2, 3, and 4, of course. All right, full adder over here, full adder over here, producing a sum and a carry, and another full adder over here producing a sum and a carry. All right, the column height is 1, 2, 3, 4. Once again over here, making use of a full adder gives us a sum and a carry, and another full adder adding these 3 bits produces a sum and a carry. All right, once again a full adder over here and another which gives a sum and a sum and a carry, another full adder at this stage with 3 inputs produces a sum and a carry, still maintaining that column height to be 4, and another full adder still which gives a sum and a carry. Another full adder at this stage, still giving us sum and a carry. And another full adder producing a sum and a carry. Another full adder at this point producing a sum and a carry. Still that condition is satisfied. Like what? Which condition? The column height should be 4 bits, 4 partial products. Alright, and making use of a full adder over here, which gives us a sum and a carry. And this bit is reproduced as it is over here. All right, so no operation, that bit doesn't undergo any operation, this bit. All right, and the next stage, the column height should be 4, so we don't need any operation for these 3 bits. So all right, so 1 2 3, still maintaining. Did we miss any bits? No. Like here 3 has come down, the column height is 4, and that column with 2 partial products and single partial product over that side, this has to be reproduced as it is, no operation. Why? Because we are in need of 4, the column height to be 4, and this is 3, all right, and this is 2, and this is 1. And making use of the same full adders and half adders, the next stage, the column height should be 3. All right, it's already 3, so no need to perform any operation for this one. The column height is already 3, nothing to do with this. So 1 2 and 3. All right, so making use of a half adder over here, this one half adder, which produces a sum and a carry to the next column, and bringing these 2 partial products to the next stage. This 2 partial products, maintaining that column height to be 3. All right, so and then comes a full adder at this point, making use of a full adder still, which gives a sum and a carry, and this partial product, no operation on this one, is brought down as it is. All right, missing any partial products? No. This one, these 2 comes down as it is, this one for this. All right, this and this, and a single partial product over there. Where are we? We introduced a full adder over here with a sum and a carry. All right, and this bit was brought down as it is, the column height is 3. Now the full adder over here, which produces a sum and a carry, and this bit is brought down as it is. Still another full adder at this point, which produces a sum and a carry, and this partial product is brought down as it is, no operation, making no operation for that one. All right, not including in any addition over there, no combination for that one. Still another full adder at this point produces a sum and a carry, and this partial product is brought down as it is. Another full adder over here, which produces a sum and a carry, and this partial product over here. Another full adder over there, which produces a sum and a carry, and this partial product as it is at this point. Still another full adder which produces a sum and a carry, and this partial product, this one comes down as it is. Full adder which produces a sum and a carry, and this partial product comes as it is. Another full adder over here, all right, which produces a sum and a carry, and this partial product is brought down as it is over here. And 2, pulling that down, that partial products over here and over here, that the column height is still 3, and this partial product is over here. Now making use of now here, this one, we started from the actual 8 column height to be 8, we reduce that to 6, 4, and the column height is 3. Next that should be 2, isn't it? So 2, these partial products 2 as it is over here. No, let me make use of another, which one, blue, so that you can see clearly. 2 partial products, this 2 partial products as it is. Why? Because at this stage the column height should be 2. Alright, so making use of a making use of a half adder over here, making use of a half adder, producing a sum and a carry. Alright, sum and a carry, and this partial product, this one is brought down as it is, maintaining that the column height to be 2. Alright, we already have a bit over here which is the carry from the previous stage. We have 3 bits over here, and so we are in need of only 1 bit over here. So making use of a full adder at this point, which produces a sum and a carry. Again, the column height should be 2. We need only 1 bit. We have 3 bits. Making use of a full adder at this point gives us a sum and a carry. Another full adder at this point, producing a sum and a carry. Another full adder at this point, full adder producing a sum and a carry, maintaining that column height to be 2. Yet another full adder over here, giving out a sum and a carry. Still making use of another full adder at this point, which gives us a sum and a carry. And yeah, yet still another full adder which gives us sum and a carry. And yeah, still another full adder at this point, a sum and a carry. And another full adder comes into the picture, producing sum and a carry. And yeah, yet another full adder at this point, producing a sum, which produces sum and a carry. Alright, a full adder at this point, producing a sum and a carry. Alright, and this one, this PP partial product is dropped at this point as it is without performing any operation. Alright, so at this stage all the column height has come to 2, and we cannot miss this. This has to be dropped down to its place. This one, this partial product, this to be dragged down, and here it's dash. That's the position. All right, so guys, the final stage, making use of a fast adders like parallel prefix adder, carry, look ahead adder, etc., we can bring it to the final partial products which we want. All right, so this comes down as it is, making use of a big one. This one comes down as it is, and making use of a half adder over here, which gives a sum and a product. See, this this half adder gives a sum and a carry. The carry is taken at this point. All right, carry from this one, and if we have a full adder over here, that which gives a sum. Even this one produces a carry. All right, even this full adder produces a carry which comes over here. All right, this carry from this one, making use of a full adder over here, which gives a sum, and still a carry from here, carry bit from this stage, another full adder over here giving a sum and a carry, another full adder over here giving a sum and a carry bit, another full adder at this stage which gives a sum and a carry. All right, we have 3 bits again, making use of a full adder which gives a sum, and still this full adder gives a carry. So making use of a full adder over here, another sum, and even this full adder produces a carry. And if we make use of a full adder at this point, that produces a sum and a carry. This full adder gives a sum and a carry this side, and a full adder at this point produces sum, still a carry bit, another full adder at this point. If the carry out from this full adder is the input to this one, once again we'll make use of a full adder at this point, which produces a sum and a carry. Alright, carry, and making use of another full adder at this point, which produces sum and a carry. Alright, and at this point once again a full adder which produces a sum bit and a carry bit. So we have done with the 8 cross 8 multiplication, which contains, like, n is 8 at this point, so the number of partial product should be 2n, which is 16. P0, P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, 12, 13, 14 and 15. So that's how data multiply works.